Hello everyone, welcome to a video for practical math. We're on week 11, learning how to use two-way tables in auto insurance. The central question for this week: how can two-way tables, marginal distributions, and conditional distributions be constructed and analyzed to determine the risk level and amounts for premiums and deductibles for auto insurance policyholders? Here's what we're going to be learning this week. You're going to learn how to create and read a two-way table. We're going to find marginal distributions. We're also going to find conditional distributions. We're going to analyze the data in the table to determine high, medium, and low risk groups. We're going to define terms like insurance, premiums, and deductible. And we're going to explain why different people pay different amounts in insurance premiums and deductibles. All right, so take notes, pause this video at any time, use the video and the reading for week 11 to help you answer the questions, work through the assignments. And if you have any questions, please let me know. Call me, email me, text, any of the above. Here we go. Driving. We love to drive our cars in the United States of America, and one of the great rites of passage is being able to get your driving license when you turn 16. If you're over 16, maybe you're looking excited to getting all the stuff, getting your permit, getting your license. I know I was when I was 16, but there you go. It kind of represents freedom. It represents being our own people. However, one of the several costs to consider when you get your driver's license is that you are required by law to be insured as a driver. As a driver, you represent a certain amount of risk to yourself and to others. Some of you may be high risk, some of you may be low risk. When we talk about risk and insurance, risk is the chance of loss or harm. So insurance people are always trying to figure out how risky is this? What are the chances of things costing money or people being hurt? Fortunately, someone came up with the bright idea of developing insurance as we were driving more and more and people were getting in car accidents. Insurance allows people to transfer the risk by paying a fee now to avoid the possibility of a larger loss later on. It's easier to pay $100 a month over the period of a time and budget that and plan that than it is to pay $20,000 when you totaled your car. The price of insurance is influenced by an individual's behavior, and insurance companies analyze the outcomes of individuals who face similar types of risks to create insurance policies. Insurance companies collect a relatively small amount of money, it's called a premium, for each policyholder on a regular basis. That's what you pay a month. This allows the company to create a pool of funds. So as all these people are paying their premiums, it gets a lot of money that kind of goes into this account, and they compensate those individuals who experience loss. A policyholder may also pay a deductible, which is a fixed amount an insured person must pay per loss before the insurance company will pay a claim. So you're paying your premium per month. Let's say you do get into a fender bender and you want to get your car fixed. The insurance may pay most of it to get it fixed, but require you to pay a little bit as part of getting it fixed as well in terms of a deductible. Premiums and deductibles are directly correlated to the level of risk an insured person possesses or poses. That is, how likely the person is to incur or cause loss or harm, and thus make a claim with the insurance company. If you are a very risky driver, if you get into accidents all the time, you're going to pay a large amount of money for premiums and deductibles because they figure you're going to be using it. Premiums and deductibles are based on the level of risk a policyholder is judged to be. The higher the risk, the higher the premiums and deductibles will be. Often, policyholders agree to pay higher deductibles in order to reduce their premiums. Okay, we made all that. Hopefully you are starting to get some idea of insurance, premiums, deductibles, things that you're going to have to deal with as you start driving. We're going to be looking at some examples now of data represented by a two-way table and seeing how insurance companies determine who is high risk and who is low risk for an auto policy. Okay, now we're getting mathematical. A group of 21-year-olds was asked if they had received a traffic ticket in the past 5 years. Below are the data collected. Let's start off by calculating the totals for each category. So we have girls over here. We can see that out of the girls in the 21-year-olds posed, 32 of them received a traffic ticket. 74 had not received a traffic ticket, but a total of 106 girls were a part of the survey. For guys, we had 60 guys got a traffic ticket and 38 hadn't received a traffic ticket. So that is a total of 98. So slightly more girls were surveyed than guys. We're getting some hard data. Now let's look at how many total this way. Those who received a traffic ticket, 32 girls, 60 guys, so that's a total of 92 people who had received a traffic ticket. And out of those who hadn't received a traffic ticket, that's 74 plus 38, that's 112. And finally, we need to total up how many total people were in the survey. So that's 112 plus 92. That is going to be 204. Okay, so there we go. We've got some numbers. 204 people were in the survey, and we know some information about if they have received a ticket or not. Okay, we've filled out our table. We now know the totals in terms of girls, guys, all this good stuff. 204 people were surveyed. Let's talk about marginal distribution. Marginal distribution is the distribution of one of the values of one variable among all individuals described by the table. Here are some questions that get into marginal distribution. What is the chance that you are female and you get a traffic ticket? Well, let's think about the numbers that we have. We know there are a total of 204 people. So that is saying, what is the chance out of those 204 people that you are female and get a traffic ticket? So we got two things to consider. So let's look at our table and look at if you're female and received a traffic ticket. That is 32 people. So our chances then are 32 out of 204. And if I calculate that out, if I divide those and multiply by 100 to turn that into a percent, that is about 15.7%. Okay, let's compare that now. Do some contrasting, right? Guys versus girls, we love to see who's better, who's not better. Let's look at what is the chance that you are male and get a traffic ticket. All right, so we're still out of 204 people surveyed. Now let's look at the guys. There are 60 guys out of the 204. So based on this population, it'd be 60 divided by 204. If I turn that into percent, that is about 29.4%. So look at this. Just comparing these numbers, you're almost twice as likely to get a traffic ticket if you're a male compared to if you're a female. Do you think insurance companies are aware of this? And there's all sorts of other things you can play around with. You can look at how many have gotten a ticket versus not a ticket, etc. But this is marginal distribution, taking the total and finding the percents out of the total for certain categories that we're looking at. Now let's play around with some other stuff. We still have the same table, same information, but now let's do some conditional distribution. So conditional means instead of looking at the total, now we're looking at specific conditions and doing percentages based on that condition. So conditional distribution, the probability that a randomly selected person or item from a subpopulation has the one characteristic of interest. So here are some conditional distributions. Given that you are a guy, what is the probability of getting a ticket? So what does this whole given that you are a guy thing mean? Well, what that means is we're answering this question, what is the probability of getting a ticket, but we're only looking at all the guys. So when I look at my table now, instead of using 204 total people, now I want to know, okay, just looking at the guys, there are 98 total guys. So out of 98 guys, given that I am a guy, I'm just looking at that population, what is the probability of getting a ticket? Well, 60 out of 98 got a ticket. And if I turn that into a percent, 60 divided by 98 is 0.61. And if I multiply that by 100, that is about 61.2%. It's a pretty high probability, right? Given that you're a guy, what is the probability you're going to get a ticket? That's pretty high, 61%. Now let's take a look at this question. It's a subtly different one. But given that you got a ticket, now we're assuming, okay, you got a ticket. What is the probability that you are a girl? So now I'm focusing on this population. Given that you got a ticket, so now I need to look at, well, how many total people got a ticket? Well, here we go. Received a traffic ticket. There were a total of 92 people. So out of those 92 people, that's what that means. Given that you got a ticket, focus on that population. What is the probability that you're a girl? So out of that 92 people, 32 of them were girls. And so 32 divided by 92 times that by 100 is 34.8%. So out of all the people that got tickets, only 34.8% of them were female. What does that mean? It means the other 66% were male. So again, this is a conditional distribution. We're looking at a subpopulation. Given that you're a guy, so we only focused on the guys, or given that you got a ticket, we only focused on the tickets. And we're having different bottom numbers. We didn't use 204. We use different bottom numbers because different subpopulation. So the Center for Disease Control, the CDC, reports that young people ages 15 to 24 represent only about 14% of the population. However, they account for 30% of the total costs of motor vehicle injuries among males and 28% of the total cost of motor vehicle injuries among females. What does that mean? If you're younger and you're a driver, you're really, really expensive to pay for insurance. You tend to get in more accidents. You have more risk. So, based on the data, that's what they assume. They're going to charge you a higher premium, a higher deductible. It's going to cost you more money to be a driver. Okay, here's another two-way table example. We're having fun with two-way tables. I decided let's do a little more complicated one. A safety officer for an auto insurance company in Connecticut was interested in learning how the extent of an individual's injury in an automobile accident relates to the type of safety restraint the individual was wearing at the time of the accident. As a result, the safety officer used statewide ambulance and police reports to compile the following two-way table of joint probabilities. So what do we have here? We have the extent of your injury, so people with no injuries, people with minor injuries, major injuries, and people that died. So we're keeping track of these variables. We also have the type of restraint. So they were wearing nothing when they had their accident. Maybe they were wearing only a seatbelt. Maybe they're wearing a belt and a harness, which would be belt and shoulder strap. Do these three restraints affect these outcomes? And you see some different probabilities. Now the way to interpret this is these all 1, 2, 3, 4, 8, 16 numbers represent a total of 1, which is like 100% of the population. So we've got these in probabilities where 0 means nothing will happen and 1 means it's everything. So all the probabilities add up to 1. And then there's our categories here as well, the totals. So let's do some interpretation of this. So this is a big table. So when I read this number right here, this means people that did not wear a seatbelt, they wore nothing, and they experienced death. So what does that number mean? It means out of all the people who drove or were in this survey, 0.025, which is the same as 2.5% of them, died while not wearing anything. Now contrast this if you wear your belt and harness. If you wear your belt and harness, there's a 0.01, which means there's a 1% of the population died, because under death, by wearing their belt and harness. So what you can see from here is looking at the total population, you're more than twice as likely to die if you're not wearing your seatbelt than if you are wearing your seatbelt, at least in terms of the numbers and all the statistics that were shown here. Now you can also compare and say, okay, out of the total population, 20% of them had no injuries. 45% had a minor injury. 30% of the population had a major injury, and 5% of the population actually died. Notice it's not related to seatbelts and harnesses or anything. It's just out of the people that surveyed, here's the population. Okay, so I think we got an idea how to interpret this. Let's look at a couple questions. What is the percent of people who had a major injury while wearing a belt and harness? Okay, this would be an example of a marginal distribution. Out of everyone, what is the percent of people that had a major injury while wearing a belt and harness? Okay, so we need to find major injury. We need to find belt and harness and find where they intersect right here. That's 0.065, which I multiply that by 100. The answer would be 6.5% of the population had a major injury while wearing a belt and harness. Okay, now let's answer the next one. What is the percent of people who had a major injury while wearing nothing? Okay, so major injury again. But wearing nothing, right here would be 0.135. That's 13.5%. You think seatbelts don't have an effect? Wearing your seatbelt versus not wearing your seatbelt can definitely make an impact in terms of if you have a major injury or not. Maybe you only have a minor injury if you're wearing your seatbelt. But there you go. That's what interpreting our table of data is showing us here. Here's some conditional probabilities. If a random person was wearing nothing, what is the probability of death? Okay. Let's pull up my pen. So if a random person was wearing nothing, so wearing nothing, now we're focusing on this 40% of the population right here. Out of that 0.4, what is the probability of death? It is 0.025 out of 0.4. I'm going to divide those two numbers. 0.025 divided by 0.4 multiplied by 100. You have a 6.25% chance. Of death if you're wearing nothing. That's kind of a high percentage, right? I don't want to play those odds. Okay, let's look at another question. If a random person gets a minor injury, okay, there's our qualifier, our condition. So now we're finding minor injuries, and it's this total. So now we're going to do out of that 0.45, or out of that 45% of the population, what is the probability that they were wearing a belt and a harness? So they got a minor injury out of that subpopulation. What is the probability they're wearing a belt and harness? Okay, let's find belt and harness. And we're going to divide it by that subgroup. So we need to do 0.115 divided by 0.45. And what we see is 25.6%. Okay, so if you got a minor injury, there's a 25% chance you were wearing a seatbelt. Or 25% of them. But it gets higher, right? If you have a minor injury, there's that higher of a percentage you didn't have a belt, and there's even a higher percentage you weren't wearing anything. But there you go. There's using conditional probability with a more complicated two-way table. So back to insurance. Obviously, insurance companies try to keep track of if you're high risk or low risk. They're taking data on all sorts of different things, right? So if you're going to apply for insurance, they want to get an idea of how risky you are. Here's all the things that they want to figure out about you. What's your driving record? Have you been pulled over? How many tickets? How many accidents? How many driving violations? If you have multiple records, you're going to be really expensive. If you don't have anything on your record, then you're less risky. They're going to look at your commute. When you apply for insurance, they ask you how far away from work do you live. If you bike to work or if you walk to work because you live so close, you don't have any commute, then you're not going to be driving as much. But if you have like a 20-mile commute every day, the more you're driving, the more likely you're going to get in an accident. You're riskier. They're going to look at what type of car. Do you drive a Porsche and are zipping around in your fast car? If you are, you're more likely to drive faster, you're more likely to get pulled over, you're more expensive and more risky. We talked a lot about this one. Obviously, your age makes a difference. If you're a little older, you're wiser, you're more mature, you don't do stupid stuff as much. They look at your credit score. If you're responsible with your credit, you're going to be more responsible with your driving. They look at your marital status. If on average, it's actually statistically shown that married drivers are lower risk than unmarried drivers. Like your gender, we talked about that. Men are more risky than women. Sorry, guys. And they look at your grades. If you're responsible with your grades, they figure you're more responsible driving. So all of these things affect how much you pay for your premium. That's what do you pay per month. And they affect your deductible. How much do you pay when you actually file a claim, when you have something happen and you're trying to get insurance coverage? If you want to, here's a website where you can go on and actually play with some numbers. You can put in your information and actually see what kind of insurance rates you would get. Maybe you're 16, maybe you're getting ready to get your driver's license and you're trying to figure out how much insurance costs. Go here is a great starting place. You can also call and talk with insurance companies and quickly get an idea of how expensive you'll be for insurance as well. Okay, what did we cover? Well, we did a lot with two-way tables, right? Reading them, interpreting them, knowing how they work. We talked about marginal distributions out of the total population, and conditional distributions where we would focus on a specific subgroup for probabilities. We analyzed data to figure out who is a high-risk group and who are low-risk groups. We talked a lot about insurance, premiums, deductibles. What do all these words mean? How does insurance work? And we explained, I think, why different people pay different amounts in insurance premiums and deductibles based on how risky or not risky you are. Okay, great video. Have a great week, and I'll definitely look forward to interacting with you guys.